you label the 1? So it says when 1 inch is folded up. So where do we put the 1? Yeah, the little squares. These are all 1 by 1 squares right now. 1 by 1 squares. So what is this distance right here if those are 1 inch right there? What is that distance? 24 minus 2. So what's it going to be? 22. And what's this distance going to be right here? Why is it going to be 16? Yeah, exactly. What's the equation for the volume of a box? Length times what? Times what? So in this case, what's the length going to be? 16. I'm going to do a longer one. I like to call length that one. It doesn't matter. I just like to standardize it that way. So it's going to be 22 times what? Times 1. What's 22 times 16 times 1? Is it 252? 352. Yeah, there we go. Thank you. Raise your hand if you're okay. Is it inches cubed? Inches? Yeah, inches cubed. Raise your hand if you're... Let's do something that's very similar. It says, what happens if it's 2 inches on a side? What happens if it's 2 inches on a side? Everybody head up for a sec. I want you to do this verbally with me, okay? Verbally with me. So if it's 2 inches on a side, the only thing that changes is instead of folding up 1 and 1, we fold up 2 and 2. Does the volume equation change? No. Length times width times height. Can someone tell me, one person raise your hand, what's the new width, what's the new length going to be? If you fold it up 2 and 2, what's the length going to be? Gabby? 20. What's the new what's the new width going to be? Someone else. What is it going to be? 14. And what's the new height going to be? 2. So if you do that out, that's 20 times 28, which is 560 centimeters cubed. Okay, let's fold up 5 on each side. Let's fold up 5. Lizzie, if we folded up 5, what's the length going to be? If we fold up 5 and 5, what's the new length going to be?
First, it's inches cubed, not centimeters.
Thank you. Well done. Okay. Nice. What's the new length would be what?
14.
Correct. What's the new width going to be?
8.
8. And what's the height going to be?
5.
So that turns into be 14 times 40, which is actually what? 560 centimeters cubed. So look. Oh, I did it again? This is why Mars lander crashed. Okay. Anyway. Volume. What's the general equation for volume? We've already written it a couple times. What is the general equation for volume? Yes. So in this case, we're going to do it in terms of x, which is the height. So the x is going to be the piece we cut out. Everybody understands that? X is the amount we fold up on each side. So in this case, h is going to be x. Now let's look at our diagram here. If we make hx, so that's x and x. Those are 2 x's right there. And there's an x and an x. What's the length going to be if it's x's now instead of 1? What's the length going to be? Like when it was 1, it was 24 minus 1 minus 1. What's the new length going to be? Yeah, Jen. 24 minus 2x. Exactly. Exactly. So the new length is going to be 24 minus 2x. So anybody want to take a stab at what the width is going to be? Nick, what do you think the width is going to be? If the, because how did we get 22, Nick? We did 24 minus 1 minus 1. But instead of 1, it's now x and x. So it's 24 minus x minus x. 24 minus x is 24 minus 2x. So what's the width going to be? Now, what's the width going to be if it's x and x?
24 minus...
Not 24, it's...
Oh, 18 minus...
Yes, 18 minus 2x. So we have 18 minus 2x. So we can plug that in and get volume is equal to 24 minus 2x times 18 minus 2x times what? X. Do we have an equation? Yeah, we're really happy about that because now it's the same process. It's the same process we did before. We have an equation that we want to see if we can find the maximum of. So theoretically, what's our next goal? We want to take the what? Theoretically, we want to take the derivative. What do we want to do before we take the derivative of this?
Multiply it out.
Multiply it out. Everybody do that right now and be super careful. Multiply this out for me and clean it up. Multiply it out and clean it up, please. Answer, you think it's 4x cubed plus 84x minus 432x?
Yeah.
Anybody agree with that?
Yeah.
Is that good?
Yeah.
I think it's good. Fantastic. So the reason we do it totally out, Nick, is now, what do we need to do now? We have a nice clean polynomial. What do we do now? We're looking for a maximum, so what do? We take the Yeah, so what's v prime gen going to be? Tell me what it's going to be. Just tell me what it is. It's nice that we have this derivative. Yay, we have the derivative. Now what do we want to do with the derivative?
Factor.
We want to, well, before we factor, we want to set it equal to?
0.
Set it equal to 0 first. So we have 0 equals this thing. And Kira, you are absolutely correct when you say we want to factor. Anybody want to guess what you can factor out? 12. So 0 is equal to 12 times x squared minus what? Anybody have it? 14x plus 36. Now you look at this and you really want to hope that this is factorable?
It's not factor.
You want to look at it and be like, well, 12 can never equal 0. So we're just looking at this right here, correct? Here's the thing. Is everything factorable?
No.
Yes. Come on. We're going to use the big kid answer here. Everything is factorable. Is everything factorable nicely? No. You can factor anything, but it's not always nicely factorable. This looks, you're like, oh man, 12 and 3. Oh, it's so close. Unfortunately, what do you need to use to solve this? What do you need to use?
Quadratic formula.
Yes, and here's what I do not want you to do at this point. So everybody heads up. Don't just write the quadratic formula. I want you to do the discriminant first. Do you remember what the discriminant is?
Yeah.
What is it?
It's everything under the bracket.
Yeah, b squared minus 4ac. So that's going to be negative 14 squared minus 4 times 1 times 36. If you do that out, you end up with, anybody do it for me? I think it's wu shi er. What is it? Wu shi er? Only one person's working on this? Come on. Really, one? What is it?
52.
52. So what's the answer going to be? X is equal to negative 14 plus or minus the square root of 52 all over what? All over what? All over what? This is literally algebra 2. 2. I would like you all to do this right now with your calculators. Tell me what the two answers are to 3 decimal places. To 3 decimal places. To make now. What do we need to make? We make a sign diagram. And we have 3.394. There's our x value. And then we want our v prime of x.
Why is the 10.606 too big?
Because look at the original box here. If x, right here, you see it's 18 right there? X can never be bigger than half of that, right? X can never be bigger than half of that.
Okay.
So if x was 10, you don't have enough. What's the biggest x could be? 9. If x was 9, then you'd cut it out and you'd have a piece of cardboard you'd fold in half and you get no volume. So it can't be that one, so you go down here and we just do a sign diagram right now. 3.394 to the left and to the right. And remember, you don't want to go too far, so maybe test like 1 and test 4 or 3. Just test those numbers. Do that right now. Test those for me. Tell me what it comes out to be. Tell me what it comes out to be. Where's the v prime we use? Where's the v prime? Oh, it's there in yellow. So what are we plugging in? Plug in x equals 3, and maybe plug in x equals 4, and tell me if it comes out positive or negative. You don't really care if it's
It's a maximum.
Yeah.
so it's positive to negative.
Yeah.
So it goes like this, plus, 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 and then it turns into minus. So it goes up and then down. Is that what we want?
Yep.
It is what we want. So that tells us when x is 3.394, you have maximized the area. The question, though, is asking what is the maximum area? So where do we plug that in?
The original.
Into the original volume right there. And what do you end up with? Plug that in and tell me what everybody should do this right. Yes. What does that have to be equal to?
It's the top.
The top. We'll call it the top, right?
Yeah.
These have to be the same, right?
Very easy.
What's the circumference of that circle? Nick, what's the circumference of the circle in green? What's the circumference? If you have a radius of r, 2 pi r. So what does this length have to be right here? 2 pi r. If it wasn't, it wouldn't match up, right? We're trying to make a perfect cylinder. Do we have any idea what the height of this thing is? No, so we got to call it what? We're just going to call it h. What's the area of this rectangle, Nick? What's the area of that rectangle? Just look at the board. Look at the board and tell me what the area is.
It's going to be
2 pi r times what? Yes. What's the area of one of these circles? Pi times what? R squared. And what's the area of the other one? Pi r squared. So how much aluminum are we using? How much aluminum are we using? Pi r squared plus? Yes. Plus? Times h. Exactly. So we have our how much aluminum we're using. We have the equation we want to minimize, right? What's the challenge, though? How many variables do we have? How many variables do we have right here? 2. We don't like having 2. We want to eliminate it. There's one piece of information, Lizzie, that we haven't used yet from here. What's the one piece of information we haven't used? Look in the first line. Yeah. Yeah, it's 355 milliliters. Can anybody tell me the equation for the volume of a cylinder? What is the volume? Is pi r squared times the what? The height. Do we know what the volume is in this case?
Yep.
What is it?
355.
355 milliliters is equal to pi r squared times h. Why is it super helpful to have that equation? What could we do with that equation, the blue one? What could we do with the blue equation? Solve for either one, r or h. Which one's nicer to solve for if you had to choose? Why is h nicer to solve for, do you think?
Because you don't have to
Take a square root. So what does h equal in this case? 355 over what?
pi r squared.
Times what? Pi r squared. Now where do you take this now? Plug it in for h, and now what's our new equation going to be? I'll write it in green. The amount of aluminum we have is what? How many pi r squareds do we have? 2 pi r squared plus what? 2 pi r times 355 over pi r squared. The h is right there. This is the h right there. Yeah, can you simplify a little bit here? It helps. What do you end up with? A equals 2 pi r squared. What cancels there? Pi in one of the r's, right? So you get what? Plus 760. Is it 7? No, 7, not 710. Thank you. Over what? Over r. So there's our area function. There's our area function. Nice. What would we theoretically do next on this? Do that for me right now. Take this right here is perfect. Yay. Very happy. So what do we do with that now? We have the derivative. What do we do with it now? So 0 equals 4 pi r minus 710 over r squared. I'm just writing it like that. So 710 over r squared is equal to 4 pi r. What should we do with that now? Cross multiply. So 4 pi r what? Cubed is equal to 710. So r cubed is equal to 710 over 4 pi. So what does r equal? The cube root of 710 over 4 pi. Do that on your calculator right now and tell me what it is to 3.